So let me start by saying I'm excited to be here. I'm always excited to share what I've learned, especially when it comes to things relating to artificial intelligence and data. I'm a real data geek, so this is me. I wanted to level set you all a little bit beforehand. Mitch gave you a kind of nice short bio for me. I'm an engineer at heart, though, so I qualified as an engineer, and I approach things in a very engineering sort of way. So I and my business really focus on implementing solutions with existing capability rather than brand new research and development. So we take existing well-established technology and use that to satisfy and create solutions. So that's the stance I'm going to come at this presentation from tonight. So so you have a level set from that standpoint. As Mitch mentioned, please feel free to ask questions at any time. Ellen is going to be monitoring the chat. I've got it open as well, but I probably won't be paying too much attention to it. But as we go, I will try and answer any questions. But we do have a dedicated question and answer session at the end. So let's kick it off. As Mitch kind of said in the introduction, AI is very complex to implement. But if you implement the kind of correct management processes, you can find success with it. And so tonight, we're going to deep dive how to select AI projects effectively, looking into a gated process, so understanding that the kind of gates for AI, the off ramps for when we want to kind of call a stop to it, and also key factors for success and those key performance indicators that are going to deliver us some results. So without further ado, let me start to dig into things. So I'm a data guy, so I'm going to start with data to level set you. And when it comes down to it, Mitch has already mentioned 80% of all AI data and data science projects fail to be deployed. And that's not according to me, that's according to various studies by Gartner. That's kind of an average of what they kind of assess. There are even other estimates out there that put that even higher, up to 87%. So clearly, it is challenging to get AI and data science all the way from initiation to the market, so to speak, whether that's internally or externally to a customer. Let's add on another statistic associated with that: 39.2% average growth in AI for the next 5 years. That's what Statistica will tell you, and that by many people is a conservative estimate as well. So clearly, it's challenging to implement, but we have definitive growth in the market space. Add to that an Accenture study, which said that in some industry sectors, some industries manage to get a 30% boost to their revenue by implementing data science technologies, both AI and data science across the board. So clearly, we can have some fantastic impact on our ROI, even though they're very challenging to implement. I'll roll in a more personal anecdote when it comes to that. 8.1% increase to fleet readiness availability. So that's a military aircraft fleet of almost 220 aircraft. And one of the more major algorithms, one of our biggest success stories, increased the availability of those aircraft by 8.1%. Some third parties said the larger project that was a part of saved the US government $1 billion. So you can see that these technologies can have some really fantastic impact across the board. One last kind of statistic that some people will also kind of focus in on, and this one comes from a McKinsey study, which estimates that 400 to 800 million jobs are going to be displaced by artificial intelligence by 2030. But by the same factor, by the same light, 555 to 890 million are going to be created. So AI is going to make changes within the marketplace. I believe the majority of people, what that's going to do is it's not going to displace their job. It's going to automate tasks within their job. So what does that all add up to? Well, it adds up to one big challenge on how to implement AI successfully. And that's what I hope we will cover tonight, and I will give you some insights into. So let's move on a step and just.
Ben, we already have one question. Would you like to
Okay.
would you like to define AI before you proceed?
It's kind of convenient that that question was asked,
There you go.
Eleanor, because I am just about to dive into exactly that. So it's like somebody set me up for that one. So thank whoever it was. So yes, I did want to. I don't know if all of you managed to attend, but Lucas a few weeks ago gave a great primer to artificial intelligence. I did want to just briefly touch and give everyone a bit of a refresher. Okay, so what do we? First off, let's define two terms. One of which is artificial general intelligence, and the other is artificial narrow intelligence. General intelligence. What is that? That's an artificial intelligence comparable to human beings. That's the sort of thing that you see all the time on Hollywood movies, whether it's killer robots or computers that can outthink everyone on the planet. Less than 2% of all AI projects fall into that category. I believe at the moment we're decades away from getting to that, possibly even longer. The complexities involved in it are huge. The returns are potentially massive, but we are a long way, I believe, from that. So let's flip to that other 98%, that narrow intelligence. Well, that's all about automating tasks, okay? And so let's dive into some of the terms there. So the terms are a bit fuzzy. The industry is still very new, so there's a lot of interchangeability used throughout the industry. I'll try and clarify where I can. But on the right-hand side, you can see these overlapping circles, okay? And quite often, AI and data science are used interchangeably. They intersect somewhat. There's certainly a lot of overlap there. But what is data science? Well, data science is actually extracting insights from sets of data. So that's usually a team of people who are investigating a piece of data with the intent of answering specific questions. Do you know what I mean? So factors of interest. They may well apply some AI techniques to do that, but they also have a lot of other techniques, statistical modeling, things like that, that they will apply. We have another overlap, which is something called big data. Hopefully a lot of you are familiar with big data. That's all about having large volumes with lots of velocity. So they create a lot of time, lots of variety. So there's lots of different types of data that are fed into that. And there's variability in all of those things. And they have a whole bunch of other V's. Somebody clearly got obsessed with the letter V when they were defining big data. I doubt many people on this call will actually have many big data problems. There's very few companies that actually do fit into those true categories. So we're not going to touch on it much. It doesn't really change too many things. There are certainly some differences when you start to get into that big data realm, but tonight we'll just assume that it's all going to be fairly consistent with smaller volumes of data, which it certainly is. So artificial intelligence, that's intelligent tasks being performed by a computer. Okay, so that's the kind of very high level, kind of loose definition of that. There are many disciplines that revolve around, that make up artificial intelligence as a whole. One of the biggest areas, and one of the ones we'll probably focus on the most, is something called machine learning. And machine learning is all about helping computers to learn based off of, without being explicitly programmed. So you help a computer learn something so it can convert inputs A into an output or outputs B. So aka a solution, do you know what I mean? So we can feed it data, and based off of how it learns from that data, it will create a solution. To do that, we collect data, we use that to train the model. So there's this concept of actually training models, and then we test it and deploy it. And from there on, we should be able to get repeatable results within limits, and we'll touch on that a bit later on. And then finally, and I'm not going to go into this in too much depth, but you may have heard of the concept of neural networks and deep learning. And in effect, that's machine learning on steroids. So it's much more powerful machine learning. It tends to be a set of nodes which all do those computations, and they're applied in much more complex scenarios, much more complex mathematical equations. But again, generally what we're doing is converting, in this case, more complex sets of A's into an output B, okay? So hopefully that's a nice kind of initial level set. What's artificial intelligence? What's the differences? As I say, we're going to focus on narrow intelligence. So it's much more about automating tasks and analysis. And we're probably going to focus mostly on machine learning. You will hear me use both AI and data science somewhat interchangeably because of that overlap. And that's where my company's experience comes from. So that's what I'm going to talk to. So that's a good way of kind of level setting us. What we wanted to do before we got too far, because this is, after all, a networking group, is we wanted to spend a little bit of time actually breaking out and having a short piece of networking. So we're going to take, I believe it's about 10 minutes. Zoe is going to break us up into different breakout rooms. But I thought it would be nice to give everyone an icebreaker. So I thought a good start point would be to talk about what you believe you could use or your customers could use in the way of artificial intelligence to solve problems. So that hopefully will give you an opportunity to talk about your business, but it will also kind of feed into the general topic. And when we come back, I'd like at least a few people to add in some of their ideas into the chat so I can kind of take a look at it. And then I will try and craft some elements of the presentation to some of those problems. So in turn, some of the ideas you talk about in the breakout, we can kind of weave into our overall presentation. So without further ado, let me pass to Zoe, who will put us into breakout rooms. So yes, real life examples of applications, or even, I think in my business, I want to use artificial intelligence to do this. So have a think about it based off of what you know today. Would be the okay, yeah. All right, that's good. So we're back to seeing the breakout chart, and how did that go? How did do people want to put? Let me just pull my chat back up. What were there? Were there any interesting examples that people can kind of put into the chat? And while you're thinking about that, I'll kind of summarize. We were talking with Kevin about a really interesting kind of scenario of monitoring a fetus kind of gestating and helping it develop its lung capacity, which is a really interesting example of what we were touching on from a deep learning sort of perspective. So lots of different variables coming into a very complex situation where there'd be a lot of testing involved. You would want to make sure you had plenty of data and plenty of results. And Kevin was also asking about kind of variances in the model, which is another thing that you kind of need to monitor, and we'll sort of touch upon that later on. So actually, there's something in the chemistry for job applicants. People already do a lot of AI-related projects in applicants. You may have, I'm sure a lot of you have already heard of predictive index. They've already introduced a lot of AI machine learning algorithms into a lot of their predictions. So it's already coming in with understanding applicants. Just the other day, I was in a Vistage group that had the same sort of thing. So that doesn't necessarily need to be artificial general intelligence. The general intelligence is the sort of thing that can really think for itself. And if you can imagine, if I give you a scenario, when you teach a 5-year-old to identify what a cup is, it's really straightforward. You probably only need to say that's a cup 2 or 3 times. And after a while, they can interpret, well, that's a cup and this is a cup or maybe a glass. Do you know what I mean? Like they can distinguish with that with very little samples of data. When you get into the AI world, you need many more samples of data, and that's just identifying a cup. So magnify that by the multiple of times there. So we're also talking about AI system automating chargeness in a hospital or emergency room. I must admit, I'm not familiar with what a charge nurse does. Can somebody fill me in on that?
Yeah, I can highlight a little bit that. So the charge nurse basically is the central neural system for managing all the activity within an emergency room. That person's looking at equipment, it's scheduling rooms, it's locating doctors, it's making sure patients are left without being seen. So we looked at a way of automating that and making that much more efficient using analytics, using data and sensors, having all the equipment, doctors, nurses, all censored so we can look at workflow and things like that. So it was a pretty interesting application. The net result had a drastic improvement with left without being seen and faster folks being seen throughout the process.
So Steve, tell me, did that actually kind of help automate a lot of the tasks for the charge nurse, and they were still there as a decision maker to kind of
it didn't
make the final call?
But it really elevated the game. And then we started to tie in third-party type data. Like, for example, we knew that if the weather got over a certain degree, you always got an influx of patients to come into the emergency room. For some reason, when the weather gets hot, people do stupid things or other things occurred, right? So we were able to factor in other things like that as a way of really being able to provide more analytics and more analysis into staffing, things like that as part of that process.
Yeah. Okay. That makes a lot of sense, and that's an ideal case where you might have lots of different algorithms that are all focusing on different things, automating different pieces of tasks, and pulling that all together as a series of threads. So that's a great example of what I will focus on a lot, which is automating tasks and not jobs. Do you know what I mean? So that's a good one. And the next one we're talking about using manufacturing in operations and IoT to providing tons of data. There's lots of use cases in that area, from what they call computer vision, which is actually focusing a camera on something. Maybe it's a conveyor belt where you're inspecting something for defects, or maybe it's a hopper that's feeding a material. Again, all of those things are to IoT sensors, which are bringing that in, and you can create predictions off of that, identify anomalies from that. So manufacturing is another great case. And then the final one, which we had from David, was contact recognition using natural language processing, which is another area within the AI space. And actually, there's many of the predictions are that natural language processing, or NLP, is going to be where the majority of growth is going to be, because there are so many different cases, everything from chatbots to spam filters to sentiment analysis, contact recognition, like responding to emails back to people. That also kind of derives out into speech recognition and other areas around there as well. So, okay, this was great. It gave me a good kind of idea of where some of the focuses are. So right now, I'm just going to collapse the chat a bit, and we'll start to move on. So now we've got an initial starting point. Let's take a look, and I want to start with looking at where a lot of projects fail, so that we have that kind of baseline of what are the pitfalls, and why do projects fail. And I've boiled this down to 3 predominant factors. So the first one is fear, and there's still a lot of fear. I did a webinar not so long ago that did a poll asking people for how much they trusted AI, and predominantly there was still a lot of skepticism, a lack of trust when it comes to artificial intelligence. And it's my humble opinion that a lot of that comes from those Hollywood movies that we talked about earlier, with kind of killer robots and people being displaced completely from their jobs. So there's a lot of fear associated around that, with AI replacing jobs, replacing people. And I believe actually what it's going to do is it's going to replace tasks, which allow those people to be more creative. But fear is definitely one of the challenges, because it's those stakeholders. At the end of the day, an AI tool can suggest to do things, or it can even control certain circumstances. But if it's being used in a decision support capacity, if somebody doesn't trust it, they're not going to use the results, and you've just wasted a lot of time and effort. So that's one area, and where we've seen kind of several cases of failure. Focus is the next one. So this is true for a lot of IT projects, not just artificial intelligence and data science projects. Focus on the business need. in particular, when you get to exciting technologies like this, and people, I hope I've just kind of opened your minds to the different things we can do with respect to AI. And actually, once you start to get into that, you can get very excited. Oh, we can do this, and we can automate this bit, and that will free up this person to do this, and that gains some momentum. The challenge is that the focus starts to dissolve away from the true business needs. What does the business need to get resolved, and what do we want to do to solve that? So focus on the business needs and the business problem is key, and maintaining that focus does, in my experience, take a reasonable amount of energy to make sure it continues. And then the last one, just because I was trying to be cute with the alliteration, is fidelity. And in this case, we're talking about fidelity of data. So do we have good data for what we're doing? Is it clean? Is it the right data? Is it accessible? Do we have the right volume of it? So there's lots of things that revolve around data. You would actually be surprised. It's becoming easier and easier to create solutions using less data. You don't need enormous volumes, but in some circumstances, you still need the right amount of data. And it's just like any other IT system, junk in, junk out. So you need to make sure that the data works in those environments, and a good assessment of that upfront is kind of key. So now we've talked about failure. Let's flip the script and see how we can kind of convert that into some success. So I'm going to start the whole funnel focused on ideation. So here's a few tips that we've learned from an ideation standpoint, and this is kind of what we were talking about from a brainstorming perspective. So what are the things that we can do with artificial intelligence? And here's a few kind of guiding principles for you. The first one is, and I keep saying it, automate tasks, not jobs. So a good kind of rough rule for this is, if something takes 1 second or less of thought for you to make a decision on, it's a good potential for a machine learning algorithm and for machine learning to step in and do it. Along with that, if it's routine, if it's repetitive, those are the things that AI in particular is very good at solving. And if there's kind of large sets of data. So looking for areas where we can automate tasks is a good start point. Back to the business value. And I will emphasize that some more. What are the areas? What are the key value areas within the business? Where does the business deliver value? Well, doubling down on that is where you're going to get those 30% increases in revenue. So the things that the business excels at is where the focus should be. And that can be either internal or external. So maybe it's in how the services are delivered to the customer, or maybe it's in the internal processes. Maybe that's your secret sauce. Focusing on those things will deliver the better results. So a good area to mix into your brainstorming. Flip that over. Of course, we have areas of business pain. Where are the bottlenecks? Where are the pain points within the business? Because if we can remove those, we can make things, all of the processes and the operations run a lot smoother. So let's see if we can roll those into the mix. And then finally, and this doesn't necessarily relate to artificial intelligence, but I love sharing this as a brainstorming technique. It's called yes and. So I always recommend if you're starting something where you want to have a creative brainstorm, the principle is nobody in the room can say no but. So there's no kind of critique. It's always yes and. And what you will find is that those ideas build on each other, and you go crazy. You go into 10x crazy land, but that's what you're looking for, because those are going to be some of the true game-changing projects that are really going to make a difference. So, and then once you've got all of those crazy ideas, then you can refine, then you can kind of purposefully trim them down. So we've already had a lot of kind of ideas. Just to add to some of the thinking there, we can have computer vision projects. So controlling material feeds in manufacturing, managing the quality control, so identifying defects, managing stock control, so identifying what stock levels we have in various different things. And even as far as facial recognition, though that's where I would encourage a bit of caution wherever you start doing things that may be questionable. Think about it heavily as to, is there a real defining need for that? So, and we'll touch on ethics right at the very end. But a natural language processing, we talked about chatbot, sentiment analysis. Can you identify how we motivate teams? Speech recognition. I'm sure plenty of people have got Alexa at home. That's great for kind of hands-off control of things, query, like automated querying. So while your hands are involved in something else, or you don't have the use of them at that particular point, even down to controlling robotics, teaching robots how to do various tasks. And my kind of passion, the area where we excel from a business standpoint, which is prediction and anomalies. So predicting when events are going to happen so I can take proactive steps. I can identify when a failure is going to happen so I can do something in advance of that, or identifying when something is outside of the norm. And that's an indicator that I need to do something different. So hopefully that kind of builds all of the kind of ideas and a little bit of excitement for where we go next. So now that we've created some ideas behind projects, what do we do to select them? And this is one of the core tenets that I mentioned when I talked and I set up the program for this. So how can we filter out and choose projects effectively? Well, before we go there, I did want to add a couple last words on some guardrails for projects. So first one is you get all excited, but you need to remember AI is not going to solve everything, okay? Just like everything else, it's not a silver bullet. It's an awesome tool for doing fantastic things, but it's not going to solve everything. So in my humble opinion, there's always that balance between should I do this with AI or with a human, and what's going to be more effective. Don't expect every project to work the first time. This is an iterative game. Some of our most successful projects have taken us multiple iterations to get to a level of accuracy that is satisfactory. So plan for that in advance. Put in place an iterative development cycle to help you get to those levels of success. So now that we've kind of level set that, how do we do that? Well, we have a framework whereby what we do is we take all of those ideas that we just ideated and we plot them on a series of charts based off of complexity versus impact. Okay, so now we have a complete spread, and then we put a grid over the top of it. And that grid kind of groups each of those different project ideas. And where I would recommend everyone starts off is in the low-hanging fruit. So these are not very complex projects, and they don't have huge impact, but they will have some impact. And the reason I suggest you start there is because they have the best chance of success and they deliver some form of results. So you crawl, walk, and then run. And so this is the area where you start to build some momentum. And throughout this presentation, I will talk a lot about momentum because it's one of those areas which will really help you get to game-changing levels. So start in that low-hanging fruit. And there's plenty to be had there. And those are the projects that you can continue to do way into the future as well. And sometimes they're great just to fit in between like the larger projects to continue to add value to the business. But next we have the what I group into primary targets. So they're more impactful projects. They're still in that lower levels of complexity. So now we're really starting to see some great tangible results. Generally, you will also find, though, that as you move into the more impactful parts of those projects, there's going to be more involvement from the stakeholders, which is why I recommend you start with the small stuff, prove out, demonstrate the success up front, and then you can move into engaging those stakeholders, showing them, demonstrating what the successes you've already have, and really kind of hone it in on the impactful things for the business. These are great areas. It's where you then in the future, once all of this is balanced out, you're probably going to spend the predominant amount of your effort. And then after primary targets, we have my favorite ones, which we affectionately call moonshots internally. So these are the things that are key disruptors. like this is the sweet spot for your business. If you get one of these right, you're going to disrupt the market. You're going to get that 30% increase in revenue. However, they are generally highly complex projects and they have lots of impact, but all of that complexity makes their success ratio much smaller. So always worth having because it always keeps the business excited and generated, but probably only one or two of them at any one given time. And be very discerning about how successful they're being and where the resources are put. So my suggestion is to spend like 60+% of your effort in the primary targets, another 20% in low fruit, and only like 20-ish% in those kind of moonshots. Because these are also going to draw your key resources, like the really skilled individuals.
So Ben, we have a question. Are the primary targets the areas where people issues rise up a lot?
Where people issues, yes, they well, both the moonshots and the primary targets, but I'm recommending you kind of start low fruit, move to primary targets, then add in kind of moonshots. So yes, as you transition from the low fruit to the primary targets, that's where there are going to start to be people challenges, do you know what I mean? Because they're having more impact on the business. And it's not, there's no golden rule here, but generally, if they're having more impact on the business, it's having more impact on the people in the business. And so that's where you really need to get that stakeholder engagement. Does that help? Does that answer that one?
I believe.
Okay. So, and then of course, bottom right, we've got highly complex things that don't have any impact. Just throw them in the trash can. They're low strategic value. Don't even waste your time. Okay. So moving on from there. So we've talked about kind of how we kind of will discern which are the right projects to do. This diagram may be certainly familiar to those of you in the IT space. There are similar kind of life cycles out there, and it's just as applicable to AI and data science projects. So we have the ideation phase, so ideate, which we just talked about. So these are where you've got some of your AI team matched up with some of your subject matter experts, involve those people who know your business really early on, and mix them up, because that's what's going to get you success for all those good ideas. And funnel them out using that kind of which projects do we chase next. Once it's gone out of the kind of ideation phase and you've selected which ones you want to do, then we would recommend moving into a feasibility assessment sort of phase. So this is where you really do a go, no go on the full up project kind of viability. So what is this doing? This is assessing the project data, assessing the project needs. So doing some initial modeling, ballparking the potential accuracy that you can get, and even kind of coming up with some initial ideas of what is the potential return on investment you can get from that project. And that allows you to go, do we want to move on to the next stage or not? After that, and there's no clear divide here, this diagram looks great, but you move into, I would suggest there's a gate, but the elements of prototyping appear in feasibility and vice versa, but then you move into more of a prototyping stage. This is where you're really starting to do some more in-depth modeling. You're confirming the accuracy of your models. So were your suppositions from that feasibility assessment good? You start to do full learning on the model. So you have a full proper test data set. You partition that up. You help the algorithm learn, and then you apply some testing to it. So you use another part of that data set to confirm that accuracy. Really lock in, is this a good model and a good algorithm or not? That's where we'll finalize the algorithm, do the development, and maybe even create some sample visualizations, which are going to showcase the results to the end users, just as an initial point. Following that, we move into an implementation phase, just like you would in kind of a software development activity. And that's where some of the software development tasks come in as well. But here, now we're going into productionizing that algorithm. So there's maturity in it, there's unit tests in it, there's that robustness to make sure that it's solid and bulletproof. We may even convert technologies from something like Python into Java, which is more performance-based. We're adding the data connections, so we're automating the data feeds to it. We're confirming the predictions and accuracy based off of that. doing the refinement, solidifying the visualizations as well. So now we have true user interfaces for people to do, and then doing that other kind of coding, application development, the frameworks, elements to it, interfaces, everything like that. Following that, we move into deployment, and deployment, just like any other thing, it's putting it into the target environment. In this case, there's more effort when it comes to load balancing. Depending on the algorithm, there may be high levels of kind of data like processing load as a consequence of some of these algorithms. So would generally recommend putting these into a cloud environment anyway, because you're going to get much more flexibility with respect to that processing kind of load. It all depends on the algorithm. We've deployed stuff on a laptop before, but deploying it into the end user environment is kind of key. And that's also where you're getting that true end user engagement. You know what I mean? If you've been smart, you'll have subject matter experts, which will bring in their stakeholders. You'll be working them all the way through. But this is the point where making sure that it transitions to those end users and confirming their buy-in and getting them using it and proving out the success for it is going to add real sort of success. And then finally, like everything, we go into our maintenance phase. And here's where we monitor the performance. We touched on this when we were in our breakout room, kind of assessing, oh yeah, just so because I've created the model and it's successful with one data set does not mean it's going to change. If you look at a big system, so let's say we use a lot of aircraft data. So let's look at an aircraft. Well, let's say I have a modernization program and I start to swap out transmissions, or I swap out an APU. These are really large components of engine. They will have influences on the system. At that point, the algorithms that you already developed are going to respond differently, and they're going to give you different accuracy. And you're going to have something called drift. So the accuracy is going to drift off over time. And that may even just be because you've got wear and tear, for example. And I'm just using a kind of manufacturing example. There's lots of different examples, even in computer vision, like cameras start to degrade, and so you get different things. Or somebody puts something in front of the camera, so now you've got less fidelity on the image. All manner of different things. You can get drift in some of the algorithms. So they need retraining, they need maintenance, and worst of all, you may have to potentially remodel the whole kind of scenario. Okay, so, and of course, eventually we may get to retire and replace it with something completely different. There's always off ramps. There's always those gates. The gates for the ideate is pretty straightforward. Do these make sense or not? The gates for feasibility, this is where you're starting to look at what's my return on investment. Is that what I'm looking for? Is this going to deliver the results I need based off of the predicted expenditure I'm going to have for that? Prototyping is where now you're starting to say, yeah, okay, so I thought I was going to get those returns, but now I've really developed it far enough. I've kind of identified not. And then, of course, some projects always kind of fail earlier in implementation. We want to strive, and I think this is fairly obvious, for gating out things much earlier in the phase, because you save yourself a lot. But there will be the occasional one that get halfway through implementation and some crazy thing happens that you're not getting the right data feed, or there's a particular lag that means that now that lag prevents you from doing the predictions in a timely manner. So it kind of calls a halt to it, those unpredicted things. But definitely think of gates after your ideation, gates after feasibility, and gates after prototyping. And I would also say, just because it doesn't pass one gate doesn't mean you throw it in the trash can. You put it on one side. You may hibernate some things. You may also identify, well, the reason I can't do this is because I don't have the data today. So now I know what sensors I need to do, what changes I need to do to start collecting that information, so I can do that next year or in 6 months' time, or whatever that is.
And we have a question about how much prep should you do as you start to deploy or before deployment?
How much prep should you do? So I would say, we kind of fluidly transition into deployment. I would certainly say I would take my implementation and put it, just like any other kind of software application, in a kind of pre-production deployment environment to test it out. ideally feeding it real world data to make sure that happens before you pull the trigger and move it into deployment. It kind of depends from case to case, do you know what I mean? But again, that deployment is where you're really, now you may have involved your stakeholders all the way through, but now that's the point where they see the results. And if the first set of results are crap, if you'll excuse my French, they're going to get switched off really quickly, and they're going to take that initial interpretation with them.
Right.
And it's going to be really difficult to bring them back in. So
I think our question is more about the people prep than the data flow prep.
Oh, okay. Yeah, I would be doing a fair amount of prep. I mean, certainly there's potential for kind of process changes. So you're going to want to do some training on that. I'm going to touch as we get further on. I advocate education for everyone as well across the board in what artificial intelligence is all about. So that's like at a general level, so people understand that. Certainly there should be a project by project level kind of follow on for that, which is, yeah, this is what it's going to do for you. This is how it's going to interact. And this is what it's going to do for us as a business. So, I mean, I'm touching in areas which I'm not an expert in, but from my perspective, if you engage employees early and explain to them why it's happening, they get much more engaged in it and see the success of it. So, I mean, so
Absolutely.
Okay, so, and then of course we've got like different projects are going to have different levels of effort, everything from really small kind of maybe quick data science projects, which will have a lower level of effort, to those big, huge kind of moonshots, which are going to have a lot more. So now we've touched on kind of project stages. Let's look at what some of the key success factors are. Okay, and this kind of goes back to that particular question. So certainly setting expectations early is a huge factor. Okay, and we would always recommend setting the expectations low and then aiming high and over delivering. And that's I don't need to tell you folks that. That's what you should do across the board. But setting those expectations is a good key thing to do early. Helping people understand. Let's take, for example, what I know more about, but a prediction algorithm. It's never going to be 100% accurate. It's going to fluctuate. Sometimes it's going to be of lower levels of accuracy and sometimes not. You will statistically norm those out for your level of expectation. But as I said earlier, AI is not a silver bullet. So helping people understand that it's going to improve things. Now, in some cases, like full automation is kind of a given, and we don't need to worry about accuracy. But in many cases, we do, and that's where you need to set those expectations, because there are always going to be false positives or false negatives that you need to kind of take into account. Next is, and I've said this a lot, is focus on projects that add momentum. So those things that they're going to give you broader adoption throughout the company. So you prove out that you have the success, and that builds that momentum on the flywheel. And as you start to build that, you get more and more returns because you can take on bigger and bigger tasks. And so focusing on those momentum building projects, and they may be different from some of the others, but those will help you to reach the ultimate success that some of the real big boy players in this market have found. Educating, and we kind of touched on this from that last question. Educate everyone in the business about artificial intelligence and data science basics. There's plenty of courses out there that will work equally for somebody in the C-suite as they will for anyone else in the business. They're 4 or 5 hours long. It's 4 or 5 hours well spent if you're intending on implementing artificial intelligence. This will help kind of build that engagement with the team. And I actually predict that as we start to automate more and more of these tasks using AI, we're going to get to the point where data science and AI kind of understanding is going to be just as an important skill as math or languages that we teach in schools, because there's going to be a lot of it. So educating the whole workforce brings them all on board, and it also helps them understand, oh, these are the results and this is where they've come from and why they've come from that. And then of course, building a good team, and whether that's engaging a company like ours, whether it's building it internally yourself, or whether it's some hybrid model of that, building a good team is going to be a key factor for success. But that team needs to involve both AI and data science experts and subject matter experts. Those are the people that are going to help you keep the focus on the business, okay, and keep that focus on those business needs, and also provide the gotchas and the kind of, no, that's a silly idea and here's why early on. We want to try and avoid some of that negativity if we can, but that partnership is fundamental. I've seen it being so much more successful when a project partners with a subject matter expert than when it doesn't. Because quite often at that point, it's what I would call a fishing expedition, and it's looking to create value when, and it may be lucky and find it, but quite often it doesn't. And that's not what I think any of us want.
Hey, Ben, before you go on, we have a question. Is it better to build a network of AI models so you can have more reuse of the models as you progress through the phase gates?
Yes, it's always a good idea to build up that library. I actually think, and I'll talk about this in a little bit, in the long run, that library of models is not what you want to focus your effort on. That library of models and algorithms in the not too distant future is going to become a commodity. There's going to be plenty of those out there. The area you want to focus on is matching those models with your data and having the right data to apply to it. One of the leading lights in the artificial intelligence arena, a man called Andrew Ng. If you're interested in further learning, I would wholeheartedly recommend looking into some of his works. He explains all of this in the most beautiful, straightforward manner that no matter how complex the subject matter, but he is leading an effort, and I believe in it, that the focus needs to be more on the data than it does the model. So previously we've had this model-centric, algorithm-centric effort. Now it's going to be data-centric. So making sure that the data matches the problem, and because I'm going to have a smorgasbord of algorithms in the not too distant future. There are already plenty of them out there. It's a case of tuning them and helping them learn. But the focus should be more on the data than it should necessarily be on the algorithm.
Thank you.
Okay. So, and then last touch point, I mentioned this kind of building momentum and a flywheel. I would also encourage you to, for the specific example, identify what is that kind of flywheel for your particular business. So maybe you have a product which has a user base. And so you start with a good product, you get some more users, the more users give you more data, which you can then use to refine your AI to get a better product, which gets you more users, which gets you more data, and so on and so forth. And that's whether it's more users to get you more data, or whether it's more examples from a production line, or whatever it is. You can create this concept of a flywheel that if you pick those right things will catapult you forwards in the long run. It will take a while to build up, but once it's got going, you're gonna really have that rocket ship to the moon. So now we've talked about key success factors. I also mentioned that I was going to talk about key performance indicators. Now, my belief is that certainly in any kind of given subject area, once you get past 3 KPIs, you're starting to lose people. So there should be 3 main things of focus. And in particular, I would look at company return on investment. So what's the return on investment you're getting from AI overall? Okay, at a company level, that's going to measure, how successful are you with all of your initiatives overall, and what value is it adding to the business. Project success rate, which is where we go from feasibility to deployment. How quickly am I developing those things? How many projects do I actually successfully get to deployment? That measures my capability at generating those AI tools. And then the flip side of that, which is delivery to use. So how many of the ones that I deploy get actively used? Because that's really a key measure of that stakeholder engagement. And did I pick the right projects? Did I pick the right projects that the team resonate with it and it adds kind of key value? I would also add in a couple of other things to monitor kind of the overall effect on the business impact over time. And not necessarily a KPI, but it's always worthwhile gathering data on the time and effort per project type, because you can that will really set you up for future project types. Oh, this is going to take me this much time. And building that library up internally is going to be great. And then at the project level, certainly model performance, how accurate is my model? What performance levels is it giving? And then return on investment for that specific project. And then just like any other IT project, agile performance, like the task times, all of those sorts of things. You should be doing this with an agile methodology and sprints and sprinting forward. So as you develop each of those different sort of phases. So I've talked a lot, and I've talked a lot about how to select those projects, the gating process, the key factors, the KPIs, all of the things that I promised I would. But I wanted to leave you with a few final thoughts, and then we'll move into some Q&A time. So first off, a note on bias and ethics. I mentioned this early on. Artificial intelligence is not unethical. It can be used for unethical purposes, but it by itself, it's just like anything else. I can split the atom for good, or I can split the atom for bad. Same is true of artificial intelligence. So always think about what's the use case, and is this use case really an applicable thing to be using AI on? Same thing is true of bias. Artificial intelligence is not inherently biased. What makes it biased is the data you feed into it. You feed it biased data, you'll have a biased algorithm. And you just need to look at Microsoft and Amazon for some good examples of that. Microsoft put an online AI tool that the internet made racist and homophobic almost overnight. So that's because it was fed racist and homophobic data. So the data in will really impact your kind of results. Flip side, using Amazon we're using resume data to do their screening. They fed in all of their existing employees' resumes. What did they get out? They get out what the developers we want are white males between the age of 25 and 35. No great surprise. They already had a biased workforce. They biased it some more. So bear that in mind. The data will bias things. Data is the new oil. It's cheesy, but it's the truth. The big tech companies have been centralizing data mainly for their advantage for many years. We've all been helping them to do it. So data is key. It's any company's secret sauce. That's where your focus should be. That's going to make you most successful when it comes to AI. Preserve it like it's a trade secret. Share it with others, but when you do, protect it. Start small, gain momentum. I think I've touched on that, but getting that flywheel moving is going to get. This is a marathon, not a sprint. Focus on problems that relate to your business. If you manufacture coffee, let's say, if you bring beans in and grind coffee, focus on things that will help improve the processes for grinding coffee or marketing your coffee or selling it. Don't try and write an algorithm to drive a self-driving car. It's outside of your domain. So the things that make you special as a business, those are the areas you should put your effort in from an AI perspective, because those are where you're going to get the returns. Not the other mundane things, because in a decade, there are going to be plenty of off-the-shelf solutions for the more mundane elements of business anyway. You can just pick those up. Focus on your secret sauce. And most of all, and I'm going to steal from Nike here, just do it. Find a project, get out there and get started, because it's an exciting world. And once you've got started, you'll really start to see the power and the impact of it. Okay, over to questions. Any other questions we have, Ola?
We have a question about lie detectors. Are lie detectors a successful application of AI or a failed?
Oh, that's an interesting question.
That's why I waited till the end.
That is an interesting question. Because I mean, that's down to what's the data that I'm getting in. Like, we can do lots of good things with data. I would say that, to me, gets to that ethical question. What am I trying to do with, why am I trying to create a lie detector? What's the purpose of that, and what am I going to use it for? I think it's probably entirely possible to do that. There's already kind of algorithms that work on micro expressions, which is one of the things that can betray things. We can feed in temperature data. For example, wear one of these Aura rings. That's monitoring my kind of core body temperature the whole time, my heartbeat, all of those sorts of things. It's possible. I'm not sure it's the best use of AI that we can have today. I mean, I'm not sure it's going to have the biggest impact. I'm not sure if that answers the question, but.
Bobby, did that answer your question? He's muted.
It gave me some input.
Okay. Yeah, it's input, Bobby. I'm sorry. I mean, are they a successful application of AI? I would argue, yes, they can be a successful implementation of AI, but maybe not where we should be expending our effort. And that's a personal opinion. Sorry, that's not necessarily helpful. But any other questions, Eleanor?
That's it at the moment. We can open it up.
Well, if we can, how do you determine how much data you need before you can start actually building the project?
So that's what would happen in that feasibility study, Bob. That's the area where you would put in place you need some experience in that team. And I would also say that when you start that team building, it's going to be tough, because the first individual you need to having some experience. There's plenty of people you could pull straight from college, but from what I've witnessed to date, you need at least that core level of experience, at least 2 or 3 years of experience to have made some of those mistakes and to understand those kind of key questions. How much data do I need for this before I even expend tons of effort in tackling it? And that only comes from experience and that kind of team understanding. But it's tough. It's a new industry. It's still forming itself. And there's a lot of competition for those kind of resources. So it depends from project to project. Some projects, I mean, you can still, and here's the nice thing, if you have the right data scientist, they may easily just be able to do a statistical model with a set of Excel data that will be a good start point. And then even if you don't have enough data today, if that produces some results, you can start collecting data and turn that statistical model into a machine learning model that will deliver results in the future. Does that help?
Yeah, well, the other side of it, which came out of our conversation in the group with Kevin, I think it was, for everybody else, Kevin was talking about applying AI to premature babies where they're immersed in a womb-like environment to improve, so they develop enough to live in a normal way without lung problems. And it seems to me, in some cases, the struggle is to figure out what's the right date. That would be an example to me of one of those, because there's lots of variables that could be impacting the maturation rate of the lungs.
That's true, Bob, and that's where there's plenty of activities that go on in that feasibility study, like a sensitivity analysis on the data, what are the impacts and what are they not, and that's why you kind of need to do some initial modeling, because sometimes you need to have that initial model or that initial version to uncover what does and doesn't have impact. And it all depends. That particular problem that we were talking about was a highly complex one, and is probably something worthy of deep learning, which is where you have many, many variables that affect many, many different things, and they get fed through this chain of multiple calculations to come out with an answer at the end.
Yeah, what had struck me in my thoughts when in our conversation, baby formulas have been several times gone through dramatic changes because they turned out to be missing key ingredients that no one ever thought you needed, didn't know about, more at the trace level. So how often do you look for partners to acquire data that might be useful? Allied industries, like, maybe for what Kevin's talking about, I would go to the formula makers and see what they have.
Yeah, all the time. If you can partner on data, then that's key. I mean, I can't emphasize enough how much the data is a driver, and it would be true in that circumstance. That's where you need a strategic partnership, though, because if the other company is smart, they're going to recognize the power of their data as well. For example, I'm going to use a trite example that Andrew NG uses, but if I have 1 million photos of cabbages and I know which cabbages are bad and which cabbages are good, I'm going to write the best cabbage health algorithm on the planet. Do you know what I mean? Because nobody else has been taking pictures of cabbages. So you're right, having the data is going to be that sweet spot. And yes, it's likely to build a whole network of future. Oh, if I have this piece of the puzzle and you have that piece of the puzzle, if we get together, we could share the results, or we could share the benefits in a kind of entirely different way. So
one of the things executives probably should think about in terms of AI is what strategic partnerships could drive success.
Yeah. What strategic partnerships could drive success? What is your data strategy overall? And that's a mix of what data do you have, but it's also what data resources do you have to process it, and what expertise and what problems are you trying to solve. And I've got a kind of separate white paper that touches on that. But yes, data strategy is key. And just like anything else, strategic partnerships can add to that, both from a data standpoint and also a kind of algorithms, tools perspective as well.
Mm-hmm. Thank you.
Okay.
Any other questions?
If AI is dependent on having the appropriate data available, then is it just regarded as a fast calculator, i.e. all it is doing is replicating what people could do given sufficient time to do it?
Yeah, the simple answer to that is yes. It takes time to train it, but yeah, that's what we're doing here. We're accelerating. So if you imagine a machine learning algorithm can do thousands of calculations in a second versus what a human could do, which is why I say focus on those projects which are a second or less of decision making, because that's usually the sweet spot of a binary decision, yes or no. Do you know what I mean? There's usually some sort of yes, no output. And that is where, yeah, glorified calculator, I'm afraid to some degree it is. Once you get to the artificial general intelligence, that's a whole different kind of matter. But yes, in the main, we're taking a bunch of inputs A, putting it through a mathematical model to get an output B, which is our answer. And that answer may control a control system, or it may light a light on a dashboard. But
can I add to what you said, Ben?
Mm-hmm.
I mentioned as people were coming onto the session, I just read an article today about the application of artificial intelligence to the venture capital industry. And the article was saying that one of the reasons they're seeing such dramatic improvements in performance is they're finding it's a way to offset bad decision making by people, the inherent biases in decisions. Because they've always noted, the industry does it. I look for deals based on my network. The industry tends to not look at women as often as men, and so on. And apparently, they're finding that it actually done properly. Yes, it's a calculator, but it's a calculator that offsets the errors we tend to put in with our internal calculators. Which was kind of fascinating, because I tend to think of AI coming out of the banking industry as related to things like credit scoring, where the problem's always been the reverse. Creates or aggravates biases, but apparently it can be fixed them too.
I agree, Bob. But I had a panel discussion and we talked about that, and that the general thinking was, yeah, it can go either way. but we could actually use AI to fix our biases. Like if you take out sometimes those elements of whether it's gender or race are kind of part of the output. But if you can take those out, like then you get plain results. And that's probably what's happening in that venture capital. They're probably not even allowing them to look at, in effect, the company resumes. It's just like resume screening. If you take the name off that and any reference to he, she, like it gets down to the pure skills of the person. You can't possibly have bias at that point until, of course, you get to an interview and then the person gets back in the loop. But yeah, that's a really good example. So I'm mindful of time, and I know we need to do a wrap up. So let me just finish by saying, and this it's been asked a few times. Yes, the presentation will kind of get sent out. Here's my contact details. I'm always excited to talk to anyone. So please feel free to reach out to me. LinkedIn's always the best place to find me. That's my social media of choice, and that's where I'm most active. There's our website there where you can go and look at some of our case studies as well to learn a bit more, or just email me directly. So, and I hope everyone has a great evening. Mitchell, over to you.
Thank you, Ben. Great job. Probably raised a lot more questions than answers, but that's the idea of the next upcoming meetings that we'll have to have.
Beacon is the premier executive networking organization serving the Mid-Atlantic region. To learn more, go to beaconforlife.org.